In the famous words of Leonard Skinner, ooh, that smell. Can't you smell that smell? And that's what we're going to be talking about today. As we get into part 4 of our senses, we're talking about the nose and the sense of smell. This is not a very complicated unit when it comes to our notes. Hopefully you'll see the complexity of the sense of smell, though, in how many senses, how many smells we can actually pick up. Today's notes are very simple. Hopefully you won't get too lost in those. Just a brief introduction. The nose, of course, is the sensory system's organ of smell, much like the ears. What we see is only part of the whole shebang. Okay, the outer nose, as we'll see in a moment, is it plays a very small role. Okay, it plays a very small role in the sense of smell. Smell is a result of airborne odorant molecules. Okay, so the smell of something is actually tiny little particles of that object. So if I was smelling cookies, I don't know why it's on my brain, but if I was smelling cookies, small little odorant molecules, tiny little particles of those cookies are actually traveling into my nose, into my olfactory receptors that we'll see in a moment. Same can be said of flatulence, a poot, right? If we smell a poot, odorant molecules from that fecal matter is actually traveling into our nose. So there's an interesting fact next time you smell something, whether it's cookies or flatulence. So odorant molecules enter in the nasal cavity and they stimulate what's called olfactory receptors. These are chemoreceptors. Hopefully you remember that from our first part of our notes. These are found at the top of the nasal cavity in a structure called the olfactory bulb, and we'll look at that in a moment. From there, these chemoreceptors are going to generate nerve impulses depending on which olfactory receptors or which chemoreceptors take in that odorant molecule, that smell. And it travels along the olfactory nerve to our brain, where the olfactory cortex makes sense of the smell. We smell something, we go, I've never smelled this before. Or we smell something, go, that is a skunk. Based on experience, I know that's to be a skunk smell. Here's just a quick overview on the anatomy of the nasal cavity. I believe this is listed in your notes, so go ahead and jot these down. Of course, you'll see this graph or this diagram again, and we're going to refer back to it as we talk about the sense of smell. Humans can detect roughly 4,000 different odors, and that's pretty dang good. There's sometimes the intensity of the odor doesn't change exactly what we're smelling. So if we're smelling cookies across a campus, that's one way. It's still the same odorant molecules. They just may not be as intense as if we're pulling them out of the oven. Same odor. So 4,000 different odors. However, we only have about 1,000 different olfactory receptors. So there's a fourfold difference that we're talking about. We can smell 4,000 different things, but we only have 1,000 olfactory receptors. What's the deal? It's actually a phenomenon called combinatorial diversity. Combinatorial diversity. There's your $3 word for the day. Combinatorial diversity. How this happens is that there are each odorant molecule can bind to several different receptors. Okay, several different olfactory receptors. I think the next slide will tell us more about that. And so whatever receptors get triggered by a smell, okay, or by an odorant molecule, this unique pattern is what goes to our brain, and it's stimulated and goes through the olfactory nerve, and our brain makes sense of it. So, an odorant molecule or a smell may trigger 3 or 4 different olfactory receptors, and that pattern is what our brain recognizes. Okay, so it's not like we need one olfactory receptor or chemoreceptor for every type of smell there is in the world. No, different smells will trigger a combination. That's what gives us these 4,000 different odors that we can smell. So combinatorial diversity. I think in your notes it has a little bit about this. Let me move my fat head real quick. I'm just going to put myself right here. Odorant molecule is what it says underneath me. So the way this works, Go to the next one. Knew it. All right, so let's say we have odorant molecule A here, okay? This is a cookie since we've been using it. This is coming in and not lining up with olfactory receptor 1. Instead, it's triggering 3 different olfactory receptors. Now, this olfactory receptor number 3, it may be used to smell this one odorant molecule, but it may also be used to smell dozens of different other olfactory or odorant molecules. Okay, so this combination is what gives us this combinatorial diversity. It's what triggers 4,000 different odors. Same can be said with odorant molecule B. It may bind with many different olfactory receptors. So if this is a fart, okay, and it comes in and it binds with these 3, this pattern is what gives us the sense of knowing somebody has tooted around me and it stinks. Okay, so odorant combinatorial diversity works like this. Each odorant molecule binds with a different combination of olfactory receptors. And that unique pattern of olfactory receptors is what stimulates our olfactory nerve, which then sends a signal to our olfactory cortex. Okay, so it's the combination of the receptors that each odorant molecule triggers. So to summarize, I told you very quickly, olfactory molecules enter, and you can see it spelled out here, enter from the air, enter the nasal cavity, smelling it in until it reaches the upper surface of our sinuses. Okay, the olfactory receptors, which are found in the olfactory bulb there, are stimulated. The cilia that's found on those. I think there's some videos that show this a little more in depth in our studies. Those activated chemoreceptors will then carry a nerve impulse from those olfactory bulb to the olfactory nerve, carries it up to the olfactory cortex. I'm saying a lot of olfactory. Okay. In essence, the odorant molecule comes in, it stimulates the chemoreceptors, which stimulates the olfactory nerve, which carries it to the olfactory cortex. And that's how our brain interprets what is that smell. Like I mentioned earlier, it may be something we've never smelled before. So our brain has to process that, and they go, well, never had this pattern of olfactory receptors stimulated. This is something new. And we'll probably investigate that and try to figure out where is this smell coming from, or smelling it again, making sense of what it may be. Most of the time, however, our experience tells us, oh, that's a cleaning solution, that's bleach, or I smell the cologne of my loved one coming in the door. So quick little quiz here at the end. Of course, you can take this on your own a little bit later.